Welcome to tonight's video on graphing the secant and cosecant functions. The steps that I outlined in the notes are as follows. The first thing that you want to do when graphing the secant or cosecant is first graph its reciprocal function, but make it very light. I usually make a dotted line. If it's the sine, you want to graph, if it's the cosecant, you graph the sine. If it's the cosine, you graph the secant. That's the first step. The second step is you're going to draw vertical asymptotes through the points where the sine and cosine graph crosses the shifted x-axis. Basically, where the sine and cosine were 0, that's where you're going to put vertical asymptotes, because the reciprocal of 0 is undefined, and whenever it's undefined, that's where you're going to have a vertical asymptote. What you're going to do when you graph the sine and cosine is you're going to make the maximum and minimum points darker so you know where they are. They're clearly visible. And then you're going to draw curves from those maximum minimum values towards the vertical asymptotes away from the sine and cosine graph. The period of cosecant and secant is equal to 2 pi times the horizontal stretch or shrink. But there is no amplitude for cosecant and secant, and the phase shift once again is equal to the horizontal shift. Alright, so the first thing that I showed you here is a example of how to graph the secant. So the first thing, it says graph f of x equals -1/2 secant x plus pi over 2 minus 1/2. And it says state the period and phase shift. Well, there's nothing to factor out, so we don't have to worry about that. So first thing we're going to do is we're going to graph the reciprocal function. So we're graphing the cosine. So that's why here if you notice, you're graphing the cosine. All right, looking at the function here, the first thing you notice is there is no horizontal stretch or shrink because there's no number in front of the x. There's no reflection across the y-axis because there's not a negative sign. There's a horizontal shift left by pi over 2 because it's plus pi over 2. There's a vertical shrink of 1/2. There's a reflection across the x-axis because of the negative sign. And there's a vertical shift down by 1/2 because of the minus 1/2. So if you make your chart with the original points, and here I did the chart for you already, you'll see that the points you end up with are listed in this last column. So when we graph this, first of all, notice that the first x coordinate is negative. So I'm going to leave some space on this side of 0, and notice that the x-axis, when we scale it, each x is pi over 2. So if I add pi over 2 to each x, I get the next one. So I'm going to put one space here, that's negative pi over 2. Then every space here is going to be positive pi over 2 until I get to 3 pi over 2. The highest it goes up to is 0, and the lowest it goes up or down to is -1, and so we'll make this -1 and this is -1/2. Alright, so when we plot the points for the cosine curve, we have negative pi over 2 and -1, 0 and -1/2, pi over 2 and 0, pi and -1/2, and 3 3 pi over 2, and negative 1. Remember, dotted lines for this, because this is not our graph, this is just a guide. So, remember, there was a horizontal shift left pi over 2 and a vertical shrink of, a vertical shift down by 1/2. So the original 0 point actually shifted to the left pi over 2 and down 1/2. So here was where the original y-axis would be, and here's where the original x-axis would be. So if you look, the points that would be 0 would be here and here. So that's where we're going to put our vertical asymptotes. Then if you look at the maximum points, you have one here, so we're going to go up like that. You have a maximum point here, so you're going to go up to the asymptotes there, and you have a point here that's going to go like this. So there's our graph of the secant. Notice first we graph the cosine. We applied the horizontal shift left pi over 2. That gave me where the original y-axis would be. The vertical shift down by 1/2 gave me where the new, or the original x-axis would be. So these points here are telling me what would have been 0 had it not been shifted. Then that's where you're going to put vertical asymptotes, because remember, the reciprocal of 0 is undefined. Then at the other points, which are here, we go towards the vertical asymptote. So, and same thing here. And then here at the minimum or the maximum point, we go up towards the vertical asymptote. Now notice there's no amplitude because this goes on forever. So the period is 2 pi because there's no horizontal stretch or shrink, and the phase shift is to the left pi over 2. Alright, so now if you notice, the next one we're going to do is a cosecant graph. So we'll graph the sine first. Now notice we're going to have to factor out the 2. So we get x plus pi over 2 plus 1. So now, when you do your transformations, there's a horizontal shrink by 1/2. Then, there is no reflection. There is a horizontal shift left pi over 2. There's a vertical stretch by 2. There's no reflection, and then there's a vertical shift up 1. So when we make our chart, we have 1/2 x, we have x minus pi over 2, we have 2y, and we have y plus 1. Our original points for the sine are 0, 0, pi over 2 and 1, pi and 0, 3 pi over 2 and negative 1, and 2 pi and 0. So half of x is still 0, minus pi over 2 is negative pi over 2, 0. Then multiply the y by 2, still gives you 0, and then you add 1. 1/2 of pi over 2 is pi. minus pi over 2 gives you, actually sorry, this is pi over 4. Minus pi over 2 gives you negative pi over 4. And then times 2 gives you 2. And then plus 1 gives you 3. Half of pi is pi over 2. Minus pi over 2 is 0. Times 2 for the y is 0. Plus 1 is 1. And then half of 3 pi over 2 is 3 pi over 4. Minus pi over 2. Remember, pi over 2 is 2 over 4, so that gives you positive pi over 4. The y times 2 gives you negative 2. Plus 1 gives you negative 1. Half of 2 pi is pi. Minus pi over 2 gives you pi over 2. The y times 0 is 0. And then plus 1 is 1. All right. If you notice, the period is 2 pi times 1/2, which is pi. The phase shift is to the left, pi over 2. And remember, there is no amplitude in the cosecant. So remember, the first thing we're going to do, and because there's some negative x coordinates, I'm going to leave space here. And remember, looking at this, the first point is negative pi over 2, but then I go to go from x to x, it's pi over 4. So every mark is pi over 4, so I need 2 marks here, and then I need 2 marks over here. Negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. On the y-axis, I need to go up to 3 and down to negative 1. All right, now I'm going to graph the sine curve very lightly. Negative pi over 2 gives me 1. Negative pi over 4 gives me 3. 0 gives me 1. Pi over 4 gives me negative 1. And pi over 2 gives me 1. So there is the sine curve. Now keep in mind that the graph was shifted, right? The graph was shifted to the left, pi over 2. So the original y-axis is here, but it's shifted to the left, pi over 2. And it was shifted up 1, so the x-axis goes up 1. So this is where the original points that were 0, there's 3 of them for the cosecant. So when you draw your asymptotes, this is going to be one asymptote here. This is going to be another asymptote right there. And this third one, because every point where the sine is 0, the cosecant has a vertical asymptote. Then if you notice, the maximum point is there, so the graph is going to go up like this, because it's going to do the opposite of what the sine was. The sine's going down like this, the cosecant's going to go up. And then here's the minimum. Notice the sine goes up, the cosecant's going to go down like that. And there is your graph of the cosecant. And then if you need to, you could erase that in there, but you don't need to. But you need to make your cosecant graph darker than your sine graph. All right, I hope you've enjoyed the video, and if you have any questions in class, I will see you during class. Have a good evening.